Welcome to Modeling Mastery, the podcast where we explore the art and science of software design. I'm Hex.
And I'm Byte. In our last chapter, we looked at architecture, exploring the different ways we can house and protect our domain model, from classic layers to modern event-driven styles.
We've established the house in which the model lives. Now, with Chapter 5, entities, we're stepping inside. We're officially moving from the high-level strategic design to the granular code-level patterns of tactical design.
This is where the rubber meets the road for a lot of developers. This chapter and the ones that follow are about the fundamental building blocks we use inside a bounded context. We'll start with the most foundational of them all, the entity.
We'll explore what makes a domain concept an entity, why its identity is its most critical characteristic, and how we can discover and model these objects to be rich with behavior, not just passive data containers.
Exactly. It's time to build the heart of our model. Let's get started with our first episode for Chapter 5.
So far, we've been operating at a high altitude, looking at strategic patterns like bounded contexts and architecture. Now we're descending into the heart of the model itself to discuss the tactical building blocks, starting with the most fundamental one, the entity.
This is a great place to start because the word entity is so overloaded in our industry. Most developers, especially those who've worked with ORMs like JPA or Hibernate, hear entity and immediately picture a class that maps directly to a database table, a container for data, full of fields with getters and setters.
And that is precisely the data-centric trap the book warns against, which often leads to an anemic domain model. In domain-driven design, an entity is not defined by its attributes or its data. It's defined by its identity. It's an object that has a thread of continuity over a long period of time, capable of changing its state and attributes while remaining fundamentally the same thing.
A person is the classic real-world analogy. You're still the same person even if you change your name, move to a new city, or learn a new skill. Your attributes change, but your underlying identity is constant. That's the core idea of a DDD entity. It's a distinct thing in the domain that we need to track individually throughout its lifecycle.
The model must define what it means to be the same thing. For an entity, that definition is its stable, unique identity. This is the primary characteristic that distinguishes it from a value object, which we'll cover in the next chapter.
And this focus on identity is what liberates the entity to be more than just a data structure. It becomes the natural home for business logic and rules. A product entity doesn't just have a price attribute. It has a apply_discount.code method that encapsulates all the business rules for how that discount is calculated and applied. It's behavioral.
So the crucial first step in tactical modeling is to adjust our thinking. We must see an entity as a unique, identifiable object with a continuous life cycle, not just a row in a database table. Its identity is its essence.
So an entity's identity is its most crucial feature. But that raises a very practical question. Where does that identity actually come from?
The book outlines a few common strategies, each with its own trade-offs. The most direct approach is a user-provided identity. Think of a username for a user entity or a government-issued tax ID for a company entity.
Right, these are often human-readable and have meaning in the real world. But this approach has risks. Users can make typos, and what happens if a unique name needs to be changed later? It can make the identity unstable, which is something we want to avoid.
To ensure stability and uniqueness, we often use an application-generated identity. The most common tool for this is the UUID, or Universally Unique Identifier. It's a long, randomly generated string that is, for all practical purposes, guaranteed to be globally unique without needing to coordinate with a database or any other system.
The third main strategy is a persistence-generated identity, which is what many developers are used to. This is where you let the database create the ID, for example, with an auto-incrementing integer or a sequence. These IDs are simple and efficient, but they introduce an important design consideration, the timing of when the ID is assigned.
Exactly. When the database creates the ID, it's known as late generation because the entity only receives its identity when it's first saved. The book points out a classic problem this causes. If you create two brand new user objects and try to add them to a set before saving them, the set might see them as duplicates because their identities are both null or zero.
This is why DDD often favors early generation. The identity is assigned by the application at the moment of creation, before it's saved. A common pattern is to ask the repository for the next identity, like product repository.nextIdentity. This ensures the entity is fully identifiable throughout its entire lifecycle, whether it's in memory or in the database.
There's also a pragmatic pattern for dealing with the friction between the rich identity the domain needs, like a product ID based on a UUID, and what an ORM prefers for a primary key, like a simple long. This is the surrogate identity. The domain model uses its meaningful identity, while the database table has a separate ID column that acts as a primary key purely for the persistence mechanism's benefit. We then hide this surrogate ID from the rest of our domain model.
So it's a clean separation. The domain gets the rich, stable identity it needs, and the database gets the simple, efficient key it wants. It's clear that how we handle an entity's identity is a critical design decision, not just a minor technical detail.
Now that we have a firm grasp on what an entity is and the importance of its identity, how do we actually go about designing one? It's easy to fall into the trap of just listing all the data fields an object might have.
That's the classic entity relationship modeling in code mistake that the book warns against. It leads straight back to an anemic model. The correct starting point is always the ubiquitous language. We need to listen to our domain experts and mine our requirements for the nouns, verbs, and phrases they use.
When we hear about concepts that need to be uniquely tracked and, crucially, that change over time, that's a strong signal that we've found a candidate for an entity. The concept of continuity is key.
Once we've identified a potential entity, like the user in the book's case study, the next step is to focus only on its most intrinsic characteristics. This means defining its unique identity and any other properties that are essential for finding it. We deliberately ignore all the other details at first to get the core concept right.
With the identity established, we then model its essential behavior. This is where we create what the book calls an intention-revealing interface. The methods we create should directly reflect the verbs and actions from the ubiquitous language. The tenant entity from the book is a perfect example. The business requirement is tenants may be active or be deactivated. A data-focused approach would lead to a generic setActive Boolean method. But the DDD approach is to model the language precisely. We create an activate method and a deactivate method. Now the code is explicit. It speaks the language of the business. Assigning these behaviors forces us to think about the entity's roles and responsibilities. For example, is it the user entity's responsibility to manage personal contact information? Or does that belong to a separate, composed person object? This analysis helps us create cohesive objects, each with a clear purpose.
So the workflow is discovery through language, defining the core identity first, and then adding explicit behavioral methods that match that language. This is the process that ensures we build rich, meaningful models instead of just data containers.
After we've discovered our entities and modeled their behavior, we need to consider how they are brought to life and how their integrity is maintained. This begins with their construction.
The book emphasizes that an entity's constructor is its first line of defense. It's responsible for enforcing the object's invariance, ensuring that a valid, consistent object is created from the very start. This means the constructor should require all essential state, like its unique identity and any mandatory attributes as parameters.
And when the creation logic becomes more complex, or when one entity is responsible for creating another, the factory pattern is the right tool. For instance, the tenant entity in the book has a register user factory method. This simplifies the process for the client and ensures that a new user is always created with the correct tenant ID, enforcing a critical business rule.
Once an entity exists, we must protect its integrity as its state changes over time. This brings us to validation. The book suggests a few levels. For simple attribute-level checks like making sure an email address has a valid format, we can use guards directly within the object's methods. This is a form of self-encapsulation.
But for more complex business rules that involve the state of the entire object, embedding that logic directly can bloat the entity. A cleaner approach is to use a separate validator object, such as a specification. The entity can have a validate method, but it delegates the heavy lifting to the validator, which keeps the responsibilities neatly separated.
And finally, what if the business needs to know about the changes that happen to an entity? The most effective way to capture this is for the entity to publish domain events whenever a significant state change occurs. This creates a record of what happened that other parts of the system can react to.
So that completes our deep dive into the entity. It is far more than a simple data container. It's a behavioral object, defined by its identity, created carefully through constructors and factories, protected by validation, and it can announce its own state changes through events. It is a living, breathing part of the domain model.